Okay, chapter 9. Rational expressions. Rational meaning they are fractional expressions and really functions. What we're going to do is multiply and divide and then simplify. Within them, we are also going to need to look for those values of x that make the expression undefined. So remember that denominators of fractions cannot be 0. That would make your fraction undefined. So we'll be talking about that domain value again. If you'll take a look at this rational expression, what are the factors and what are the terms, because I have that backwards, within this rational function? So remember, terms are within an expression. They're separated by the addition and subtraction. Of course, we have one that is a monomial. So one of the terms is x. This is a term. It's also a term within the x minus 2, a term of x, and a term of negative 2, and then a term of positive 2 with x. So those are the 3 different terms throughout this problem. Now factors are what are multiplied within a problem. So if you look here, what is being multiplied? X with x minus 2, and then we have x plus 2 times x plus 2. Those 3 things are factors. X, this lone x on the top, the x minus 2 is a factor, and each x plus 2 is a factor. They are an entire unit. Let me go back. It is important to know the difference between terms and factors. When we simplify, when we divide, factors are those quantities that can be canceled out, what can be divided. Terms cannot be factored or canceled out. This particular x, which is also a factor, is kind of an exception, but it's because it is a factor. Okay, let's factor and simplify x minus 5 over 5 minus x. If you look at this, it appears not to be able to be factored. X minus 5 does not factor at all. 5 minus x is a little unique in that it can be factored in terms of it is paired within this problem, sort of, with x minus 5. We can somewhat change this by taking out or dividing out a negative 1 out of each of those terms. This positive 5, if I divide out a negative 1, becomes a negative 5. And this negative x becomes a positive x if I divide out a negative 1. If I switch these around, put the x in front and then the negative 5, I have x minus 5. This matches the x minus 5 atop. So those 2 factors will completely cancel out, and when you do that, you actually have a 1 left over on the top. So you have 1 divided by negative 1, which gives you an answer of negative 1. This first problem on the page over here, there's nothing to factor in to the 5th power. N minus 6 is as simple as it can be. This n squared minus 6n is greatest common factor. Factor out an n, you have n minus 6, you have n over n to the 8th. This n to the 5th minus n to the 8th, you can cancel those out. All of n to the 5th would cancel, and you would be left with n to the 3rd. So you would have an exponent of 3 here. And then you could also cancel that single n, and that would leave this to be n squared, as you can see in your answer. Well, that should be an exponent. And then, of course, n minus 6 and n minus 6 completely cancel out. Now, if you have all of these canceled out, this left you with a singular 1. This left you with a singular 1. This left you with a singular 1. You have 1 over this is n squared. We were changing these exponents. That's where our answer comes from. It is of note that this next problem is a division problem. We do not divide fractions, and you have not since you were a small child. So your first fraction stays the same, becomes multiplication, and we flip this one over so we have x on top, and then the 4 minus x, which you can factor out that negative 1 and change these 2 numbers. Positive 4 becomes negative, negative x becomes positive, which you can switch those around, but if you look, this doesn't match with anything, so it's really no help. So we could just leave these 2 factors the way they are. What does cancel for us? X and X. So all we're left with is the 2x plus 1 at the top, the 4 minus x at the bottom. That gives us the answer. And then down on the very next problem, we have difference of squares. So we get x plus 3, x minus 3. And down here at the bottom, this does not match up with x plus 3, x minus 3. But if you factored out a negative 1, you could change the positive 3 to negative, and the negative x to positive, which really matches up with x plus 3. And so this cancels my x plus minus 3, rather. And then we can reduce 4 over 8, rather 8 over 4, and we are left with 2 at the top here. And then this is a negative 1 dividing into a negative 2. When we get negative 2, we have x plus 3 left. So this is really an exercise in remembering how to factor. So again, you'll be flipping this over. This is kind of a long MA process here at the top to give you the s minus 5, 2s plus 3. This is right here recognized, oh, I have 2 of these s plus 4s. This is another MA. And remember, since we flipped, we have s minus 5 here, and you have an s plus 4. So what cancels? One of these each. Remember, you only cancel one top with one bottom. Of course, you might be able to do that multiple times, but you're looking 1 for 1. So all I have is one single factor at the top, the 2s plus 3, and then an s plus 4, and an s minus 5 at the bottom. And that is our answer. Exercise in factoring, once again. Okay, on this page, of course you can factor it and you can practice this. All MA happening here on this problem. What I want to point out to you is both of these, A and B, are division problems. This looks like multiplication, but remember, to the negative 1 power means you're dividing by this, so that means you will keep this first fraction the same. This means division, so we will have a multiplication problem, and you will flip this fraction over, the second one. We'll have x squared plus 4x minus 5 on the top, and then 2x squared plus 2x minus 12 on the bottom will be how this problem reads. The same thing for B. This will be our first fraction, and it will say divided by this fraction, and when you change it to multiplication, you will flip this over. So the y squared minus 3y minus 18 will be on the top, and x squared minus 12x plus 32 will be on the bottom, and make this a multiplication problem for the end as you factor so that you can cancel out. And that is 9.1. Factor, 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 factor.